Hi everyone, welcome to another impromptu gentle introduction to, and in this one we're going to be doing a gentle introduction to the Google AI Studio, specifically Google Gemini Flash Experimental in combination with some code, predominantly JavaScript, but we're going to start off in Python. Now, this was a video I've been planning on doing for a little while. What I was going to put it off till I did some other experimenting, and then I was sort of inspired, if you like, to put it out earlier because a friend of the channel on my Learning C Reasons and Resources video had made a very nice comment and was thanking me for putting the video out, but also had mentioned that they're learning JavaScript and also C++. So I thought it would be interesting, seeing as I was using JavaScript to interact with Gemini Flash, I would bring that video forward and put it out now. So here we are. So I'm going to walk through what I've been working on and talk through how you can interact very simply, very basically. This is no frills to this, with the Google AI or the Google Gemini API. And as I go through, I'll sort of explain a few caveats and a few restrictions I placed on myself. I am going to be putting the code up on my GitHub, and I'll include a link to that so you can play around with the code. But again, it's very basic, and it's not intended for in production use. This is just me messing around, as I like to do now. And also, I just explained the first bit actually, because in order to get this to work, if you want to play around with this and run the JavaScript, which is embedded inside HTML, or one of the versions are, and I'll show you some different versions we've got here. If you want to play around with that, the only extra thing you need is you do need to have an API key. Now this is really easy if you already have a Google account, so like a Gmail account or anything like that, where there's a Google account attributed to it, because you can go in through your Google account, go to the AI Studio website, logged in through Google, and I'll include a link to where I am here, and you get an API key. I'm not going to create one here because that's something you'll need to do. The other nice thing about going into this is it gives you instructions on how to do basic curl requests to the API. And this is what I used as my sort of starting point when I was doing this. I hadn't actually bothered reading any of the instructions in here. There is an API quick start guide. You'll also notice if you go back to the original screen, you can actually get the code for this, and it will create Python code, including some extra bits and pieces that you can do, because that's made easier by the fact it's using the Gen AI library from Google. Now, in this particular video, I'm not going to use that library, basically because when I started doing this, I wanted to really start from basement level with no help from any libraries. And the logic behind doing that is I had been minded that I was going to port it to different languages. And so I wanted to not lean into quite so many libraries in Python, to just make it easier when I was sort of migrating across. But like I said, if you want to play around with the actual library as well as the LLM, then yeah, you can go through and just get the code here and just copy and paste that into your Python interpreter and run it. The other thing is it's got really useful links here, so you can go straight in and read the API reference. I do have some experience of using APIs and issuing sort of endpoint requests to them. mainly Spotify and Last.fm, so I didn't really read much. I let so how this panned out, just to be fully transparent here, is I took that original code and then, using a combination of initially ChatGPT and then rather meta using the Google AI Studio, is I got it to suggest code and code changes, and then I sort of I, if you like, course corrected it at certain points or modified the code a little bit. Just basically tweaks here and there, and doing very much the sort of exploratory coding that I was talking about in a previous video, which nowadays I think with the use of AIs is often referred to as vibe coding. But I suppose my version of it is really vibe coding with a little bit more hand on the tiller as you go along, and maybe dialing back as well. So I'll sometimes ask it to do something simpler. I might ask it to actually remove code as well as put it in, and we'll see why in a moment, and various choices I made. So I'm going to run some examples at the end of this. I've got some demo code, but what we're going to do is we'll take a look at the actual code in Visual Studio. Now, long-term viewers of the channel, particularly ones that look at my coding videos, may know that usually I would use, for Python, I would use, the whole IDE is the Anaconda suite, but within that I use Spider basically. But it doesn't really matter, you just use whatever you're comfortable with. And the majority of this anyway is going to be in JavaScript. It's just me being me. I can't resist it. Whenever I start a new project, I always tend to start it in Python, particularly when I'm doing like requests. I just find it easier to from the data science aspect, I suppose, and the fact that I've done courses on data science where I've had to engage with endpoints before and online data, and so I'm so used to sort of doing that and unpacking JSON in Python. I tend to start off in there while I'm getting my head around how I'm going to parse various things. So this is a really early Python version, and I think it's the only version I did. Everything after this is going to be in JavaScript, okay? But this is a really good way of just seeing how things hold together on a real, ground floor level. We're not using any libraries apart from requests, because we need that to be able to do the post requests. So I have loaded that up, but I'm not using any of the Google Gemini libraries. So I've got a couple of global variables I'm defining here. This is where, if you want to run any of the code I'm showing you, and you'll see this again and again in the code, you need to put your own Gemini API key. Because I'm not going to give mine away, and neither should you. This is not intended as production code. This is just something that people can play around with. And then if you were thinking about creating production code for such things, you would need to obfuscate your API key in some way, or utilize it in a way that it's not going to reveal it to anybody using it. Also, I've hard-coded the model in here. At the moment, this is the one I'm using. Now, the experimental one, I don't know if I really pointed it out there, but if we go back, there we go. The experimental one is, if we look at it here, the output is, you can see it's basically free to use. Now, of course, this experimental version could be changed, could go offline, so that will certainly break the code at some point when and if that happens. However, the whole point with this is I'm expecting both myself and anybody that wants to play around with this code to sort of come in and try some different models and, have ways in which they might want to modify it, that sort of thing. And again, remember, we're using this off of the web. So obviously you need an internet connection. It's not like a previous episode where I was using a local instance of a llama, and in it I was actually running DeepSeek and a few other large language models. Now, that's not to say you couldn't implement something similar that way, but that's not the way we're going to be doing it in this episode. We're using the online API, the Google Gemini one. So first thing we do is construct the API URL. We've got this F before here. If you're not familiar with Python, it's the way in which you can, I can never say the word interlopate. Anyway, basically it's how you can insert variables into a string here. So we need to insert in the model and the API key. Now I think the original version of this that was suggested by the large language model when I was putting this together is to actually sort of embed these here and here respectively, which you can do, but I just wanted to keep this outside for any easy future changes. So that's our URL constructed. Also what we need to do is to define some headers, and we've got them laid out like this so you can sort of see the construct a little bit easier, but you'll see in some of the JavaScript ones it's condensed down a little bit. And same with data. So we've got the header, so we've got the URL, we've got the header, and we've got the data. Now anybody that's sort of familiar with data structures will probably recognize this sort of almost like a dictionary arrangement. You know, maybe you've seen lists done in a similar way in languages, that sort of thing. I'm trying to remember all the different names they're called, but I know in some they're often referred to a dictionary where you might have, you know, a key and then the actual content going on here. So you can see we've got several. We've got the contents, the parts, and then within the parts we've got the text and then the actual text. So this is the actual prompt that's going to go to the model. So then what we've got to do is create something that allows us to wrap up the URL with the header and the data request, this is what's happening here. So then all we've got to do with response, our constructed request, we just apply this method to the response, the JSON method for that particular. And of course, remember, this is all coming down. So this, we've imported the request library. We've used it here to create this construct. And then we're then using it. And it's basically calling a method that it's got from our original request library. And of course here I'm using what do they call it, like IntelliCode, whatever, so I can actually see, you know, what's going on to some degree under the bonnet there, in case I needed to do that. So let's look at what the code might look like in JavaScript. I say might because it obviously can be done slightly different. Obviously we're taking advantage here of the fact that we're pretty lean in terms of our libraries, and also the other thing, up to this until we get to the very end one, we're going to keep everything in a single HTML file, and then I'll show you at the end how that's broken down when we get onto the final example. So we want to keep things fairly simple. Just to make this fit onto one screen, I've taken out all of the sort of help stuff here, but you can see based on how this is laid out, you know, we've got our HTML header. This is the no error checking version, by the way. We'll talk about a little error checking version in a moment. We've got a button on here, and when I run this you'll see exactly what this looks like. And we have an area for our response, very simple area for our response, and then we've got the function, which is obviously, as you can probably see, you know, the function contains similar things here. Now we could have put all of this if we wanted into a function as well, but at this point we haven't when we were doing the Python version. But you can now see in the JavaScript version we've got this nice function. Okay, there's all our keys. You know, the which would go here. Our constants, we've got again our URL, our header, our data, The layout's very similar. We've got this fetch command, which is going to take our URL, the method we're using, the headers, and the data. And then we're going to get back a response from this. There's no catch block, no response, so we haven't got any error checking on this. Pretty simple. Okay. What might it look like with a bit of error checking in? A bit of minimal error checking. So, same sort of stuff at the top. A little bit more commenting here. Yeah, just a warning here, never to expose your API key in the client-side code in a production environment, because this is, client-side code. So again, why I've got here, and you'll want to experiment. And then if you do ever make it in production, then got to find a way of not exposing your API key. Notice how in Java as well, it's packaging up the URL. Slightly different way of laying it out. You can see here it's using this sort of dollar symbol in front of the variable to push that into the text. Headers again, data again. Notice as well we're hard coding the prompt in here. All of these we've actually been hard coding the prompts. There's going to be no interactive box for this particular version of it. Because at the moment we're really just playing with the concept. And you can see now for the fetch and the then, it's a bit more complicated. So we've got a little bit of error checking. We're just checking for status codes and then seeing whether, it's successful. We've got an error back because it wasn't a successful code. And then we're going to try and pass the JSON response, but also we've got a way of catching an error if the API call just generally fails as well. And we can set up quite a complicated set of cascading checks really, just to do different things, but very sort of basic at this moment. And again, you can tweak all this as well. Now, saying that, I haven't specifically tried to cause this to fail at this point. All of this code has been really minimally checked. It's really early stages, but I just wanted to get out there because I thought it'd be fun for people to just play with the basic concept and allow you to sort of gently introduce yourself with real minimal amount of code to the idea of interacting with the Google Gemini API. But certainly you'll be able to improve on this. You may pick up things when it doesn't throw up an error correctly, those sort of things. I do know if I try and run this, I do get problems with, it does kick up an error because it's got no API key. So yeah. But in the version I'm going to show you, I've substituted out the API key. So when we come to run it, it's going to rerun with API keys in, but you just won't be able to see them. So now we start to move on several iterations. So my goal after I'd sort of kicked the tires and got familiar with, okay, how under the bonnet does this work if I mainly hard code everything? Now we're moving on to actually getting to the end idea, which is to create something which would generate a learning plan for me. A few mornings before I started doing this dabbling, I'd been reading another article about this whole 40 minutes for 30 days thing. It's been around for quite a while now. And so I thought it'd be interesting to create a curated prompt to do that. So the idea is that it takes a subject and then it constructs around that subject the same basic prompt to ask the sort of question, how can you create a learning plan for a 40-minute, 30-day learning exercise. And so you'll see in a moment we've got a number of sections we need to do that. So we need to enter the subject we want to learn. Also, there's the ability to enter a direct prompt without it going through the sort of curation. And there's various other responses. So these are all divisions within the body of the HTML. And you can see I've packaged everything into one single file. So we've got all the styles for all the different components, which is pretty important if you want it to look nice. Then we've got the body of the text, and then we have this very basic script. Yeah, little bit of error checking, but not much else. So it's got two requests it will need to do. It needs to do the send plan or the send prompt. So the send plan, it's sending a prompt, but before it sends the prompt, it takes the subject and embeds it inside of this bigger prompt where you can see where it's doing it. So that now becomes the prompt for the plan. Sends it to the LLM, and we do this send request of the plan. And the send request is down here. So this is this bit we saw at the start, really. Okay, this is pretty much not changed, except instead of the prompt being hard-coded in, it's now passed into the function. And then this second one, you can see same sort of thing, but this one we really just want to put in whatever the user typed in. We don't need to curate it in any way. We don't need to package it up. And there we have it. So that's all in a single file. Now, alternatively, and probably the way that it should really do it, and I just packaged it up this for when I was testing, it made it easier and to share it, is to do it this way, is to have your HTML component with your references to your style sheet and your script. So the basic body is the same. We've got the same divisions within here. The bit that deals with the planning prompts, the bit that deals with the alternative prompts, and then this little bit where the response is going to be. If we look at the JavaScript now, you can see we've got, entering a subject, and also there's this check to make sure you've entered something. If you don't, you get a warning pop up. There's our wider prompts that we're going to encase our subject in. So there's our generate send plan, there's our generate send prompt, there's our send prompt request. So we've just basically taken the monolith file and subdivided it into different components. This is now this is now script.js, this is now style CSS. Now I've removed, there was some parsing in this to try and endeavour to take the prompt, the return, that comes back, the response, and to convert it to some sort of HTML structure. Didn't go so well. Again, this is in certain languages you get some nice libraries for doing this, but I again wanted to keep it super simple, and I must admit I do quite enjoy bizarrely playing around with JSON structures and trying to parse them. So that was more a sort of project for the future. So I've done a little bit of wrapping shenanigans, CSS shenanigans, to basically show this in a presentable manner, or reasonably presentable manner on the screen. But you'll see in a moment where there's room to actually play around with that response and actually try and parse sections of it based on certain characters that you'll see crop up. The other thing is there is a little bit of a guardrail on the very crude guardrail on the bit that does the plan, in as much as at the very end it says, for programming languages do not include code. There's two reasons for that. There's one, I was having real problems trying to parse code, so I sort of gave up fairly early on, and that was my get out. And then I realized that actually I didn't want a lot of code in the plan, because the whole point of the plan was to go away and the planning itself became part of the learning. And if I left code in there, it would mean that that was likely to get copied and pasted instead of following the plan. I would just be copying and pasting sections of the plan. And part for me of learning a new subject is actually putting the learning materials together. That's all part and parcel of it. So that was the other reason. But it's an incredibly crude guardrail, but it works reasonably effectively. And I'll show you in a moment. There's a hack in this where you can actually take the guardrail off. And then finally we have our little servitor. So there is a file here which I'm going to also upload as part of this to the to my GitHub. There's a PNG file with a sort of black metal mav, and you can see here it's actually got transparent background. So with this you can basically take any small image PNG, and you want to make it around this size. Don't make it too big because it could slow things down, and don't make it too small because it could get a bit grainy. The CSS actually squishes it down. There is a bit in here specifically for the image, which will get it down to the right size. So somewhere in here there is a image container thing with the heights and all that sort of stuff. But you could take any image and give it the name servitor.png and then put it alongside the files when you run this. So, and of course running it is just a simple thing of clicking on it because it's HTML files. And that was one of the reasons why initially I made them just completely standalone. It was just easy for if I wanted to sort of send it around just to do some testing. So yeah. So what I was going to show, I'll just show you the Python version so you can see what the raw Python. So this is a raw Python one. Not much interaction going on here. We could do, a thinking feedback thing if we wanted to, but the idea with this is it's incredibly basic. At this point, if we'd had a problem, we would have got something back. So there you go. So that's what the JSON response looks like if we just literally print it. And you can see there's certain indicators here which we could use for parsing. You can see there's some end of line stuff. You can also see that text is not the only component in here, not the only part. And down here you can see other parts as well that may be of interest to you. Okay, so if we move on to the very simple JavaScript versions. So if you remember, the first one was very simple indeed. So just to remind you of the basic code, there you go. So I'm just going to click that. I didn't want it to just run on loading, so I needed to have that. So we're going to call the Gemini API. Again, I could probably have some sort of thinking progress bar across here with, I don't know, cats coming across. So yeah, you can see, and again, I've really just printed the screen, but just the way it renders in the browser is slightly differently than when I do it in Python. But you can see spreading over the screen right over here. It's just I'm not wrapping this at the moment. But this way it's pretty easy to see where all the parts of the JSON are. The version which has the error checking in it doesn't really do anything different at this point, but if I was to do something crazy like take the API key out or I don't know, disconnect my internet, then yeah, we get some error checking shenanigans going on. It's interesting as well when you run this a couple of times, Going to get slightly different answers. The other thing to remember, I didn't point it out initially, but in the Gemini thing here, you can play around with the temperature when you get the code, and you'll notice the code has control over other configurations. So I don't know if I mentioned it, but one thing you can obviously do with this is play around in the code that I'm doing and do additional things. So as part of that posting, part of sort of getting the response, you can issue or have additional things in the JSON request if you want to control a few other things. Interesting. So I got some references here as well. So then we get on to this, which is the 40-minute, 30-day learning plan. These are actually, look the same. This is the monolith version in the single HTML file with all the JavaScript and CSS in the file together with the HTML. This one, if you were to look at the code, is the standard, is the HTML version with the script and the style sheets as external files. So in this one, the monolith one, the actual only external file is the little Mav icon. So if we were to do this, so we're just going to do Lua. Now, the way this is geared up, it actually shows you what prompt's getting sent. So that's the prompt that's getting sent. I'm just going to grab that because I want to show you what it looks like without guardrails on it. So this is a simple guardrail. So for programming languages, do not include code. Now, the purpose of this send direct prompt is really, if you see something you're interested in, obviously after you've copied pasted the response, because you probably want to keep the response, you can then send other responses without going through the that sort of prompt mangling, whatever you want to call it. Or I can do this. So I'm just resending it as a regular direct prompt. Same thing, but without the no code guardrail. So we'll see what happens this time. It may or may not give me code. It depends on how helpful the LLM is feeling. And you can spot that usually it sticks out like a sword. There we go. There's an example of it. What it looks like if you include code in there. And again, and this is something for the future, is for me to play around and start thinking about how can I get this to be rendered. Are there libraries I could use in JavaScript maybe that could help me with that, make it a bit easier, or do I want to write one myself? Let's do another programming language. So what I would suggest you do as well is, if it's a language with an unusual name that's likely to get confused with something else, then definitely say the whatever programming language. So generate plan, boom. It just the way it is, it doesn't clear out. I haven't got any code to basically clear the prompts out, so it always just shows the previous thing. So you can see what it's done, the programming language. Yep. And there we go, tips for success. Now the nice thing with this, if I just run that again, is I can change this prompt. So I can maybe ask it things like strategy. I can say, I can change the code, the underlying code, and go in here and maybe tweak a little bit if we got the code here, where is it there? So this bit here, I can maybe modify this, because maybe I want to ask it about online resources. Might be a good thing to ask it about as well. So there's something you can change around with it. And I have played around with versions where that's the case, but I wanted to just simplify this a little bit. So yeah, you can just change that yourself. And then finally, just to show there's no funny business. So this is, like I said, the one where it's sort of individual components, so HTML file, JavaScript and style all as individual files, but the same sort of thing. So it looks the same, oops, behaves the same. You can see this gets pushed down the bottom, by the way, if you're wondering where it goes. But I found it really handy just for debugging purposes, but then going forward, in case I wanted to grab it quickly before the answer went, I can sort of do that again. In fact, it's reproduced down here, so you can grab it down there thinking about it. Yeah, it just pushes it down to the bottom. You don't lose it unless you rerun. So I can do this if I want to if I'm interested in playing around with this, I can say fundamentals, master fundamentals. So including online references, maybe could do something like that. Again, like I said, you can just change this permanently in the code if you wanted to. Oh, I put including. Yeah, I might get a bit confused there. Normally it does a pretty good job of error correction by whatever means it's using, either probabilistically or through some other means. Thinking a bit longer here. I think to deal with my spelling mistake. A little bit more detail here. Yeah, can you see? So, and again, we've taken out the coding guardrail. So yeah, we've got more code in here now. So yeah, so it's just again, I want to try and make this as flexible as possible for people to play around with, but not go too far, because where would be the fun in that? So thanks once again for watching. If you wanted me to do any more videos like this in style in the series, because this is going out as a gentle introduction, and let me know. Plus, if you got any ideas for maybe modifying this, I wouldn't be averse to doing a follow-up video at some point in the future. Thanks once again for watching. Bye for now, and I will catch you in a future episode.